Walk into a commercial hatchery where newborn chicks are raised under artificial heat lamps, and you'll find a high-stress environment. The birds frequently engage in brooder chaos, aggressively pecking at each other's toes, eyes, and feathers. This behavior is the result of the chicks' pre-programmed foraging drive firing in a vacuum. Without a mother's beak to direct their focus, their instincts are redirected toward the only targets available, their nestmates. The survival system is active, but it is operating without its intended maternal counterpart. A baby chick's early survival relies on a rigid, hardwired bio-acoustic matrix, a physical soundboard inside its brain that requires a specific set of frequencies to function. This programming begins well before the bird ever sees the light of day, starting roughly 24 hours before the chick breaks out of its shell. During this window, the mother hen emits a low, continuous murmuring. Known as the maternal incubation cluck, this acoustic signature penetrates the shell and ripples through the amniotic fluid, striking the embryo. This sound locks into the chick's developing nervous system before birth. By the time it hatches, the chick is already tuned to its mother's specific vocal signature, allowing it to filter out the noise of every other hen in the barnyard. Chicks hatch with a nervous system already primed for these maternal signals, ready to respond to the first call they hear. This table outlines the bioacoustic frequency blueprint. While chickens hear up to 4,100 Hz, critical reflexes are keyed to narrow bands. The 1,000 to 1,500 Hz band triggers the aerial alarm call, a hiss used when predators are overhead. When this sound enters the chick's ear canal, it bypasses the forebrain, the area responsible for cognitive processing, and strikes the brainstem directly. This triggers an involuntary contraction of the skeletal muscles via the spinal cord. The resulting adrenaline shot causes the chick to drop flat and remain completely motionless within milliseconds. The frequency functions as a neural override, bypassing cognitive choice to activate the chick's survival reflexes from the outside in. Shifting up the spectrum to the 2,000 to 3,000 Hz range, we find the tuck-tuck-tuck food call. Chicks possess an innate drive to follow rapid acoustic rhythms. This specific frequency acts as a motor activation trigger, forcing the chick to locate the source of the sound. This loop, called tidbitting, directs the chick to the mother's beak, where it observes her pecking at a fruit source. The physical reward of a seed or bug provides the positive reinforcement needed to cement the behavior. Through this assisted exposure, the chick's brain learns what is safe to eat without the risks associated with independent trial and error. At the highest end of the spectrum, between 4,000 and 8,000 Hz, is the piercing PPP distress cry of a cold or isolated chick. This specific frequency registers as an intense physical stressor in the mother hen's nervous system, causing her heart rate to spike and breaking her current behavioral pattern. The hen immediately drops low and fluffs her feathers to provide body heat. She remains in this state until the chick switches to a low-frequency purr, which signals that the stressor has been removed. This reciprocal acoustic loop ensures thermal regulation and flock cohesion, relying on synchronous neural triggers rather than situational awareness. This system is designed to be temporary. Around week 6, as the chicks grow adult feathers and gain the ability to regulate their own heat, the mother's prolactin levels, the hormone driving her maternal drive, plummet. The inviting maternal calls disappear. If a chick tries to approach her while eating, she responds with aggressive throat growls or territorial threat calls. If the chick ignores these warnings, the mother will deliver a sharp, physical peck to the head or back. The biological link is severed. The mother now perceives the chicks as direct competition for resources rather than vulnerable offspring. The chick must now pivot its survival strategy, consciously extinguishing its innate drive to run toward the mother's voice. It must learn to interpret a complex new matrix of signals, including the alpha rooster's calls and the general alarm signals of the adult flock. Survival now depends on learned social cues, such as adopting a submissive crouch to navigate the adult pecking order. The maternal acoustic loop acts as a biological bridge, sustaining the animal through its vulnerable stage, until its own conscious brain is ready to take the lead.